Welcome everyone to this week's Feliciano Live. We're here today with Dr. Rashmi Jain. She is a professor here at the Feliciano School of Business in the Department of Information Management and Business Analytics. Today's topic is artificial intelligence. As we progress through our questions, feel free to ask a question and Dr. Jain will answer them as we go along here. So welcome, Dr. Jain. Our first question is, what is artificial intelligence?
So artificial intelligence, as the term itself literally means, is the intelligence of the machines. In another way, it's the intelligence created by human beings. I know some of my colleagues would probably not agree about that, but machines that have been developed, machines that have been enhanced to be able to think like human beings. There are different levels in artificial intelligence, and we'll talk about them as we go through the questions one by one. But artificial intelligence is where machines learn how to make decisions, how to take information from different sources, how to be able to take information in a very integrated, holistic manner, and it ranges from, the Siris and the Alexas of the world, voice-activated sensors and, language-based analytics that we are seeing more and more today. So artificial intelligence ranges from some very basic machine learning aspects where we teach the computer how to think to very enhanced levels which we haven't really accomplished that state yet. In fact, if I may use the word that somebody once used, was we are really at the cave painting phase of artificial intelligence right now. So we have a long way to go in terms of how machines will be able to think like human beings, to be able to make decisions like human beings, and to be able to make connections with sometimes similar kind of data and sometimes very unrelated kinds of data when they see that the decision that needs to be made or the problem that needs to be solved needs all this multiple sources of data. So it's not just something where we code an algorithm and we say, well, if the user inputs this, then the machine should go through these kinds of data sets and come out with an output. That's really not true artificial intelligence.
Thank you. For those who just joined us, we're here with Dr. Rashmi Jain, a professor here in the Department of Information Management and Business Analytics at the Feliciano School of Business. We're talking about artificial intelligence. If you have any questions, feel free to ask those as we move along here. Second question, what are the common uses for AI?
So AI is being projected to be used or proposed to be used by many industries, and there is a strong feeling among the subject matter experts and among the industry leaders that we have to be very careful about where we should be channeling our knowledge and our efforts in the AI area, and that is what has given birth to the Deepmind concept. So a company was launched, Deepmind, in 2010, and which has later been taken over by Google, which is Google Deepmind. And the whole idea of Deepmind was to make sure that we are directing our efforts in AI towards positive applications, towards things where we can add solutions to the day-to-day problems of the community, and where complex problems have existed, but we haven't had the computing power, or we haven't had the systems that can deal with complexity of those complex problems in a short period of time. So some of the I would say more areas of complex problems are some of the diseases where we would like to know in advance about whether a patient is suffering from a disease much before the symptoms become evident. For example, dementia and Alzheimer's, and many of these problems where it's too late when things get diagnosed. So looking at some of their language patterns, looking at some of their behavioral patterns, looking at some of the pre-symptom or pre-evident symptoms areas, and be able to get the diagnosis done much early, and so that the disease can be managed much faster. I think one very relevant and area that is AI is being used currently is in the intelligence community. So in the old days, intelligence community would wait for the data to come in, and many times the mainframes would have so much data, but they would actually not have methods of going through that data. But now they are able to not just look at the data which is directly being collected, but also some of the trends and the patterns and the buzz going on in social media, because of our ability to also analyze unstructured data, do text mining, do audio mining, be able to do visual mining of things. And so face recognition, all of these together, when they come together in an integrated platform, they really add a lot of value in our understanding of very complex problems.
For those who just joined us, we're here with Dr. Rashmi Jain talking about artificial intelligence. Our next question is, what is machine learning and how does it relate to AI?
So machine learning, as in my first question, when I defined AI or what that means, I said developing and enhancing machines to be able to do thinking and make decisions based on the data that they have. So machine learning is one of the methods or tools for doing artificial intelligence applications. And machine learning is basically helping a machine to be able to make decisions. So enhancing machines to learn by data. And in machine learning, we have several levels. So it ranges from supervised to semi-supervised to unsupervised learning. So how do we make machines learn? A common thing you would think is that the more data that a machine crunches, the better it gets to know. So if you want to predict, something about, let's say, for what kinds of symptoms would lead to an accurate diagnosis of a certain kind of cancer, and if you feed in symptoms of 100 patients, that is not going to be very helpful for a machine to learn. If you give 10,000 or 100,000 or million or multi-million records of data, the machine becomes better at learning. So when we go from supervised to semi-supervised to completely unsupervised learning, we are saying when we are doing supervised learning, we are telling the machine, giving accurate data so that the machine can look at or the computers can look at some historical data. And then second level, which is semi-supervised, is we say, okay, here's some data, historical data, and then the machine also looks at some of the patterns and trends that it sees by itself by looking at data for a long time. And then, of course, unsupervised is where which is I would say the highest level in terms of the AI, artificial intelligence, getting closer to artificial intelligence, is when the machines are able to look at the patterns in unrelated areas, in multidisciplinary areas. So, for example, in this example of cancer diagnosis, the machine might be able to look at and find that sources of genetics, and then look at not just one generation of genetics, but look at a whole community, a whole nationality, a whole geographic region in an area. So machine learning can range from very basic to very advanced AI.
Speaking of AI, can AI be hacked?
Just like any computing device, AI can be hacked. Unless we make AI as advanced as where it can foresee the exposures of hacking, and be able to develop a self-awareness to manage that exposure. In fact, just the other day, we were at a conference and we were talking about these, the antivirus applications, and one wonders that at this point, when we have become so sophisticated at, developing software which is, can be made virus-free, then why do we need this market of antivirus, applications? Similarly, if AI advances to that level where it can foresee exposures, then it should and is able to be self-aware and create mechanisms to protect itself, then that's a different point altogether. Otherwise, yes, just like any other computational device or a computing device, AI can be hacked as well.
Continuing on with AI, should we fear the future of AI as it relates to employment?
This is a question which comes up all the time, and I think in the immediate future, there is a big need of AI professionals. In fact, companies are really desperately looking for AI professionals and AI subject matter experts, and university can't keep up and keep pace with the developing new programs and new curriculum around it. So in the immediate next few years, we will see lots of AI job creations, and I think it might seem like we are going to lose jobs, but I think if we do a good job of planning, retraining, and reskilling of our workforce, and applying application of AI and robotics and autonomous supervision of vehicles, and then I think we'll be able to protect the jobs, not really protect the jobs as they exist today. For example, I can give you our New Jersey state example. We just did some work, and the transportation, logistics, and distribution, TLD area, industry sector, is one of the fastest growing in New Jersey. They expect it to grow at 45% growth rate in the next 5-10 years, and I think by 2020. And but when you look at the workforce, you find that 50% of the workforce is high school diploma and below. Now, those professionals, and obviously it's an aging population, and half of them would retire in the next few years. But when AI and machine learning and some of these robotic applications are going to be applied to TLD, which is I think a very ripe industry for such application, you will find that new jobs will be created, and I don't see a world where humans will not be supervising machines. So a lot has been written about this, in fact, about the need for humans to be able to manage the machines, to be able to obviously design the machines and use them for the applications.
Final question, is it concerned that an autonomous AI system could become malevolent or develop volition and turn on us?
Well, I think the development of AI right now is not at a point where we can project, what it is going to be capable of and turn on us. As I said, we are really in a very infancy stage of AI. And I think how we create them, how we develop them, in fact, one of the aspects that is often talked about is that in initial levels of AI, when we develop the algorithms, some of our prejudices and some of our stereotypes and some of our biases get in. And at some point, we would think that AI would be able to diagnose those biases and prejudices and be able to self-manage itself. So the point is that it's too soon for us to make any predictions about, I think it would take us at least 50 years to be able to get to a point where we say, oh yes, we have been able to accomplish as much as we wanted in the AI area. Right now, it's being driven by very immediate kind of solutions where humans and computers are not able to, computers as we know them today, are not really able to solve some of those complex problems. So there is a fear, and I think industry leaders like Elon Musk and Bill Gates and others have commented on these on this very question. It will all depend on the direction that we take and how we manage and how we design humans to be part of AI. I mean, right now I think they are talking about something like 15 trillion investments up to 2030 in the AI market. So if we focus on solutions as as Deepmind, Google Deepmind initiative focuses on things which will help us solve those problems which otherwise have not been able to solve. And especially in, me being a faculty and a professional in business analytics area, we see the convergence of quantum computing, text mining, artificial intelligence and machine learning, all of these to be able to create a platform where we will be able to do faster, much bigger volume of processing, and of course different types of whether it's text and audio and video and so on and so forth. So I think we are very early in the stage to be able to predict anything like that, but we'll see how things get there.
Okay, before we conclude our session, can you touch upon our program here at the Feliciano School of Business?
Absolutely, I would love to. So we have both the undergraduate and the master's program. Our graduate program comprises of 10 courses, and it is focused on helping students develop the skills that are needed to manage, not just do development effort, but also to be able to manage projects, define the complex systems projects where analytics adds value to the business and also adds value to the community at large. So our 10 courses comprise of all the topics that we have discussed today. They include machine learning, artificial intelligence topics, cloud computing, AWS. We also get into optimization techniques and of course text mining, non-structured, unstructured data mining is also an important. And the last part of the MS program, which we call Master of Science in Business Analytics, is about one semester long capstone practicum where our students go and work on a real industry project and are advised by faculty in application of what we have covered in the coursework in the program. So we have grown in the last 1 year and we continue to grow in the graduate program as well as the undergrad program. And our contact for MS program is, or the business analytics program is bizanalytics@montclair.edu.
So thank you all for joining us. We'll see you next week. And thank you, Dr. Jain, as we talk about auditing black box AI with Dr. Applebaum. That'll be next Thursday at 1 o'clock. So until then, enjoy the rest of the day.
Thank you.